On January 13, 2025, a Dragon took flight. Not a mythical beast, but a technological marvel, the Smart Dragon-3 rocket, or SD-3. Launched from a mobile platform off the coast of China, South Dakota, 3 soared into the sky, carrying a payload of 10 satellites. This wasn't just another launch, it was a statement. China is entering the commercial space race with a roar. The SD-3 is a symbol of ambition, innovation, and a future where space is open for business. This launch was the 5th successful mission for the SD-3, solidifying its reliability. More importantly, it marked China's first sea-based launch of 2025. The SD-3 is leading the way, proving that the ocean is not a barrier but a launch pad to the stars. As access to space becomes more affordable and reliable, new possibilities open up. Imagine a world with faster internet, global connectivity, and advanced Earth observation capabilities. The future of space is here, and it's launching from the sea. Why launch from the sea? It seems counterintuitive. The ocean is vast, unpredictable, and unforgiving. Yet it holds the key to unlocking the true potential of space exploration. Sea-based launches offer a unique set of advantages that traditional land-based launches simply can't match. Safety is paramount in any space mission. Sea launches provide an added layer of security. By launching over the ocean, rockets are far away from populated areas. This minimizes the risks associated with launch failures, ensuring the safety of people and property. The vastness of the ocean becomes a safety buffer, a vast expanse where potential risks are mitigated. Economics play a crucial role in the space industry. Sea launches offer significant cost advantages. Mobile platforms eliminate the need for expensive, fixed launch sites. This reduces infrastructure costs and increases launch flexibility. Rockets can be launched from different locations depending on mission requirements, optimizing for factors like weather and orbital inclination. Mobile platforms can be quickly deployed and prepared for launch, reducing the turnaround time between missions. Sea-based launches, with their emphasis on safety, cost-effectiveness, and efficiency, are poised to become the new normal in the space industry. The Smart Dragon-3 is more than just a powerful rocket. It is a marvel of engineering, designed to conquer the challenges of spaceflight. Standing tall at 31 meters, this technological behemoth weighs a staggering 140 tons. Its size and power are not for show, they are essential for carrying significant payloads into orbit. The SD-3 boasts an impressive payload capacity of 1,600 kilograms to low Earth orbit. This means it can carry a variety of satellites, from small communication satellites to larger scientific instruments. Developed by the renowned China Academy of Launch Vehicle Technology, the SD-3 is a testament to China's growing expertise in space technology. Solid fuel is denser, allowing for a more compact rocket design, and it is more stable, reducing the complexity of handling and storage. It is a reliable, versatile, and powerful launch vehicle, ready to meet the growing demands of the global space industry. The successful launch of the Smart Dragon-3 comes at a pivotal moment in the global space race. Private companies like SpaceX and Blue Origin are making significant strides, challenging the traditional dominance of government agencies. SpaceX, led by Elon Musk, has revolutionized the industry with its reusable Falcon 9 and Falcon Heavy rockets. The company's ambitious Starship program, aiming for interplanetary travel, experienced a setback with the recent explosion of Starship 7 during a test flight. Despite this, SpaceX remains a formidable player, securing high-profile contracts and pushing the limits of reusability. Blue Origin, founded by Jeff Bezos, is another major player in the commercial space sector. Their New Glenn rocket, designed for heavy payloads and human spaceflight, recently achieved orbit, though it suffered a booster landing failure. The Smart Dragon-3, with its focus on reliability, cost-effectiveness, and sea-based launch capabilities, offers a unique value proposition in this competitive landscape. While SpaceX and Blue Origin focus on reusability and heavy lift capabilities, South Dakota 3 targets the growing market for smaller satellite launches. The space industry is no longer a two-horse race. This competition will benefit everyone, driving innovation, reducing costs, and making space more accessible for all. The rapid growth of the space industry, while exciting, presents new challenges for commercial aviation. As launch frequency increases, so does the potential for disruption. Flight diversions, delays, and safety concerns are becoming increasingly common, highlighting the need for better coordination between the space and aviation sectors. As rockets like SD-3 become more commonplace, airspace management will become increasingly complex. Flight paths will need to be carefully planned and coordinated to avoid potential collisions with launch vehicles and space debris. Environmental concerns are also coming to the forefront. Rocket launches release exhaust gases and particles into the atmosphere, potentially contributing to air pollution and climate change. The rise of space tourism adds another layer of complexity. Safety protocols, traffic control procedures, and environmental regulations will need to adapt to this evolving landscape. As both sectors continue to grow, finding ways to coexist safely and sustainably will be one of the defining challenges of the 21st century. The Smart Dragon-3 is not just another rocket, it represents a paradigm shift in the way we access space. Its cost-effectiveness, efficiency, and sea-based launch capabilities are poised to revolutionize the commercial satellite launch industry. This has profound implications for a wide range of sectors from telecommunications and internet connectivity to Earth observation and scientific research. The traditional model of satellite launches, relying on expensive government-operated launch vehicles, is becoming increasingly unsustainable. SD-3 offers a more affordable and accessible alternative. Its solid-fuel design and mobile launch platform significantly reduce launch costs, making it a viable option for smaller satellite operators and emerging space nations. This increased affordability opens up a world of possibilities, fostering innovation and democratizing access to space. The increased launch frequency facilitated by SD-3 is another game-changer. SD-3's mobile platform and streamlined launch procedures enable a higher cadence of missions, reducing wait times and accelerating the deployment of critical space infrastructure. This democratization of space will have far-reaching consequences, empowering new players, fostering innovation, and ultimately benefiting humanity as a whole. The roar of the Smart Dragon-3 as it launches from its sea platform is a sound of progress. It signifies more than just technological advancement. It heralds a future where space is no longer the exclusive domain of governments and large corporations. SD-3, with its emphasis on accessibility and affordability, is democratizing space, opening up a universe of possibilities for the benefit of all humankind. Imagine a world where high-speed internet is available to everyone, regardless of their location. Imagine a world where farmers can monitor their crops with unprecedented precision, where disaster relief efforts are coordinated with real-time data from space. This is the future that SD-3 is helping to create. As space becomes more congested, ensuring the safety and sustainability of space activities will be paramount. International cooperation will be essential to develop comprehensive space traffic management systems, mitigate space debris, and ensure the long-term viability of space exploration. The legacy of SD-3 will not just be measured in the number of satellites it launches or the technological breakthroughs it enables. Its true impact will be felt in the countless ways it improves life on Earth, connecting people, advancing knowledge, and inspiring future generations to reach for the stars.